All right, let's get on to what we call a crusty, hairy problem, to say the least. And let's see if we can make some sense of this tamale. So we have a conic tank with the vertex down. And hopefully you've done some of our practice problems that look similar in that we've dealt with conic tanks. It's basically, it's like a cone that's three-dimensional. Think of like a funnel. So maybe if we have something like this. It's a horrible drawing to say the least, but that's what we have right there. Okay, I'm just going to say this is my diameter. Okay, so we have a conic tank with the vertex down. Okay, so this is my vertex right here. And it's 10 feet across. All right, so maybe I'll just put like a little 10 right here, 10 feet across. And the top is 18 feet deep. So from the top right here, so from here all the way down, it would be 18. Okay, so they're just kind of telling us how deep this cone goes. Now, if the water is flowing into the tank, okay, so here's our little pipe, and we got water that's flowing. So if the water is flowing into the tank at a rate of 9 cubic feet per minute, okay, so that's how much is being filled. Find the rate of change of the depth of water when the water is 4 feet deep. So when the water is going to be 4 feet deep, so wherever that is in here, so when it's 4 feet deep, find the rate of change of the depth of water. So as the water is filling up, maybe like it's filling up right here. What's the rate of change right here? Is this thing going like a foot per second, 2 feet per second? Is it less than a foot per second? So we want to know how high is this water level rising when the water is 4 feet deep. Okay, so that's what we're trying to find right there. Once again, our goal is to try to find some kind of relationship, some kind of formula that we know that deals with all these variables. And it seems that we're going to have to use the volume of a conic tank. Hey, what do you know? And so the volume of a conic tank is 1/3 pi r squared times our height. Okay, so let's think about this here. I'm trying to figure out when the water level is going to be 4 feet deep, and I can't say where that's at because I'm not sure how much water it takes. So what I'm going to have to do is that I'm going to kind of create like a little triangle right now. So I'm going to kind of just go like this and make this go down. And I'm outlining this right. So here we have a triangle, right? And I don't know the height and I don't know my radius. And so like I'm going to call this right here my R. I can't give any numbers to these because I don't know how much water is in here when it's 4 feet. So that's why I'm just going to have to use arbitrary numbers. As you can see, if I have two triangles, I have my 10 over 18 and my R and my H. I can actually create a proportionate triangle or a proportion, and that will help us because I need to get rid of one of my variables right here, you see. And if I can write R in terms of H, then that's going to help us out. So watch this. I can say that my radius, R, is going to be divided by my radius up here. Well, what's my radius up here? Well, just 5, right? So the radius of my small triangle and the radius of my big triangle is 5. Now, my height now of my small triangle is H, and my height of the big triangle is going to be 18. So let's go ahead and solve for R. So I get 18R equals 5H. Again, I'm trying to solve for R right now. So R would be 5H over 18. So since we know what R equals, we can go ahead and do some substitution now. As I do this real quick here. All right, so I can substitute this guy right here, right, for this guy right here. All right, so let's go ahead and substitute and see what we get. So volume equals 1/3 times pi times R. I'm going to replace R with 5H over 18 squared times H. And see, this is very nice here because if we think about this here, if we only have H, then that means that we can only deal with one variable. And so check this out. that means this is volume equals a third times pi 25 times pi squared. Let's see, what's that going to give us? 324. Oops, 24. So this is a 324 right here times h. So our new volume then, if you kind of put this all together here, I know it's a little bit crusty to say the least right there. But actually, let's do this in. Once we have that, we can now, let's put this together here. Let's do this. A third times pi. I'm just going to kind of leave this right here because I'm going to take the derivative here in a second. Times h cubed. All right, let's find a derivative, because isn't it that we're trying to find the rate of change of the water when the water is a certain amount of feet deep, right? So really we're trying to figure out dh dt, but they tell us what the rate of change is of the actual volume, which is going to give us our 9 right there. So let's do this, y'all. Don't try to creep. The derivative of the volume, dv dt, right? I'm just going to, this is just a variable. Oh, I'm sorry, this is a constant number, constant number, constant number. So really, I'm just going to bring this 3 down, right? I'm just going to kind of bring that 3 down right there. So I'm just going to get a third times pi times 25 times 324 times 3, 8 squared, right? And then I have to multiply that by dh dt, once again, because when I took this derivative, I took it with respects to time right there. All right, this is pretty crazy right here. Crazy bean. So let's just look back on our problem and see what information is given to us, because we either need to have a dv dt or an h or a dh dt if we're going to try to solve here, okay? It says that if the water is flowing into the tank at a rate of 9 cubic feet per minute, if the water's flowing inside, doesn't that mean volume? So that means my dv dt, right here, that means my dv dt is 9. I'm going to replace this right here with 9 right here, because it says that's what the water's flowing into the tank. And we're also told that find the rate of change of the depth of water. See, depth is the same thing as our height when the water is 4 feet deep. So that means that they tell us that our h is 4. So I can replace 9 with dv dt and replace 4 with h. And that means we're going to solve for our dh dt. So a lot of plugging in. And dv dt, so I'm going to go ahead and plug in a 9 right here. And that means, let's see, I know that those are going to cross out, so that's nice. So I'm going to get 25 over 324. Plug in a 4 squared times dh dt. Okay? Let's try to work this out as much as we can here. If we clean all this up, that's going to be 9 equals 100 pi over 81 times dh dt. Okay, so if you clean all this up right here, we get that. Lastly, I want to solve for dh dt. So let's just multiply by the reciprocal. So multiply by 81 over 100 pi. So if we do that, then we're going to get 729 over 100 pi equals dh dt. Woo! And I think that answers the question there. It wants to know, let's just make sure here. It says, find the rate of change of the depth of water. Depth means the height. And there it is. We found this means the rate of change of the depth is 729 over 100 pi. Cool beans.